Okay, inverse function part 4. Relation between f and its inverse. How we see the relation between f and its inverse. First, f and inverse of f, they vary in the same sense. What's that mean? This means either they both are increasing or both decreasing. 2. If, for example, x equal k, constant number, is a vertical asymptote, then the inverse of x equal k is y equal k is a horizontal asymptote. B, if y equal k horizontal asymptote, then the inverse is x equal k vertical asymptote. If y equal ax plus b, it's an oblique asymptote, then we replace instead of y x and x by y. Then instead of x, y here we put x, instead of x we put y, then we will have x equal ay plus b. Now go and find y. So ay equal x minus b divided by a, we will get y equal x over a minus b over a. It's the inverse of y equal ax plus b. Fourth thing, this is very important, the curve of f, and we are going to see them now in the example, in some exercise, and the curve of f inverse, they are symmetric with respect to the equation of the first bisector, y equal x. This is the symmetry. This is the inverse, right? Let's start the first exercise. F of x equal x squared plus minus 2x plus 1 is defined on 1 over 1 plus infinity. We have to draw the curves of f and its inverse, f inverse, on the same graph. Then we have to find the f inverse prime of 1, and this is very important. We have it in official exams. We are going to have this in official exams. It is very important. We will see how to do it. Now let's go and draw x squared minus 2x plus 1 and its inverse. Let's see if it has inverse first. Okay, so let's start. F of x is equal to x squared minus 2x plus 1 over, he says, over 1 plus infinity, right? First, is f of x defined over all r since it is polynomial function? Yep, that's true. So it's defined over 1 plus infinity, and it's also continuous over 1 plus infinity. Second thing, we should find the derivative. Sorry. I'm sorry. F prime of x equal 2x minus 2. F prime of x equal 2x minus 2. This is the derivative, right? Let's draw the table of variation. Table of variation of this from minus infinity to plus infinity. Oh, sorry, it's not from minus infinity. Okay, it's from 1 to plus infinity. We need only to discuss this part only, this interval. F prime of x equals 0 when x equal 1, right? When x equal 1. So it's 0 here, right? F prime of x. And if x equal 1, how much is y? Substituted in the original equation. It's 1 squared minus 2 times 1 plus 1. It's also equal to 0. So, and this is f of x. F of x, it goes, if x equal 1, it goes from 0 and up, right? Because if 2x minus 2 greater or equal to 0, this means when x greater or equal to 1. So from 1 and up, it's always positive. It's always positive. So the function increases. Also, f of 1 is 0. Limit of f of x as x tends to plus infinity is plus infinity, right? So it's increasing function. Then f inverse exists. Now what is f prime of 1 we said? It's 1. It's 0. And if the inverse, if the derivative, sorry, is 0, this means we have horizontal tangent at this end point, of the interval. Remember, this is important. Horizontal tangent. We will see what do we mean by that. F, it goes from, as usual, from 1 plus infinity to its domain, to its range, 0. plus infinity. And since the inverse exists, so it goes from 0 plus infinity to its range 1 plus infinity. Okay, let's see what do we mean by that, or how can we draw them. Before we draw, let me find very important point. Very important point. Let me first try to have the, okay, coordinate axis. It's just hard to draw. Okay, leave it like that. It's all right. Okay. This is the coordinate axis, and this is the y-axis, and this is the x-axis, right? This is the y-axis, and this is the x-axis. Okay. First, we know that the curve and its inverse, both are symmetrical with respect to this line. What is this line? It's y equal x. It's the first bisector that bisects the first portion and the third portion, right? So it's the first bisector. This angle and this angle are equal, both equal to 45 degrees. All right. Let's see first if the curve I'm drawing, if our curve, which is y equal x squared minus 2x plus 1, if it cuts this, right, this straight line, y equal x squared minus 2x plus 1. Okay, and we have this straight line, the first bisector, right? If we have intersection, this means y of the curve equal y of the straight line. This means x squared minus 2x plus 1 should be equal to x. Let's take x to the same side. X squared minus 3x plus 1 equal to 0. Right? We find delta here. Delta is b squared, which is 9, minus 4ac, which is 4, which is equal to 5, a positive value, two distinct and real roots, right? Let's find these roots. Alpha is minus b, which is 3, minus radical delta over 2a. 3 minus radical 5 over 2. And beta will be 3 plus radical 5 over 2. All right. The function is defined, the real function, the f of x, is defined from 1 to plus infinity. And this value, if we find it by calculator, it's going to be less than 1. So this is a rejected value. It's not in the domain. So the accepted value is only this one. Okay? Since this is the accepted value, 3 plus radical 5 over 2. All right? Let's see how much is that. It's a 3 plus radical 5. All right, it's 5, right? Radical. Where's the radical here? It's radical 5, okay, plus 3 equal, all divided by 2. It's going to be 2.61. It's approximately 2.61. Okay, 2.61. How can we get benefit from this? First, since it is the intersection between the curve and the y equal x, if I said that x is 2.61, this means also y is 2.61. So we can draw it. 1, 2, 3. It's approximately somewhere in the middle, a little bit more. And also, we are going to find that the ordinate is to 0.61. Okay.